6th grade, it's Mrs. Roselle. Today we're going to be doing a virtual lab. So it's going to be really exciting, but you need a few things before we begin. First, you're going to need your science textbook. This is what mine looks like. Page 176 and 177. You're also going to need your activity manual, page 111. So make sure you turn there. Now, if you look at the materials on page 111, you need goggles, 3 plastic cups, metric measuring spoons, 30 milliliters of 3% hydrogen peroxide, thermometer, 5 milliliter yeast, 3 stirring sticks, stopwatch, 30 milliliters water, 5 milliliters salt, 30 milliliters vinegar, 5 milliliters baking soda, red, green, and blue colored pencils. Okay, so for the goggles, I have glasses, so I'm just going to wear my glasses. If you're doing this with a parent or an adult, which you should be doing this with, you can put sunglasses on, or if you have silly glasses that you can just cover your eyes with something. If you also have glasses, go ahead and put those on as well. There's not a huge reaction, so you should be okay, but just better be safe than sorry. Now, for 30 milliliters, I don't have a milliliter measuring cup. All of mine are at school, but I found out that 6 teaspoons, that's right, 6 teaspoons equals 30 milliliters. And for the 5 milliliters, 1 teaspoon equals 5 milliliters. So as long as you have measuring spoons, which I do, okay, then you can go ahead and do this lab. Now, all of these are pretty much household items. We have vinegar, baking soda, salt, I have some water in here, yeast, and hydrogen peroxide. Now, when it comes to a thermometer, regular digital thermometers that you use when you're sick, those won't work, so don't use one of those. If you have just a plain, not digital thermometer, or if you have a meat thermometer, which I have, and I know a lot of people do when they're cooking, then you can also use that as well. So, before we begin, we are going to look at the types of chemical reactions that we're going to be talking about today in our lab, hot or cold. So when we talk about chemical reactions, we're going to look at page 176. At the top it says, chemical reactions often show visible signs that something has taken place. Sometimes a solid substance appears in a solution. A color change might also indicate a chemical reaction. Another sign of chemical reaction is whether heat is produced or absorbed. An endothermic reaction uses thermal heat energy, so the temperature of a solution experiencing an endothermic reaction decreases. An exothermic reaction produces heat. The reaction raises the temperature of the solution in which an exothermic reaction is occurring. In this activity, you will combine substances to determine whether the reaction occurring is endothermic, exothermic, or even a chemical reaction at all. Okay, so first we got to look at our problem. It says, how can I use temperature to determine whether a chemical reaction has occurred? So we have 3 cups. I have my 3 cups. I just use plastic spoons or plastic knives for a stirring stick. I've got 1 set, 2 set, and 3 set. Okay. My measuring spoons. I also have a piece of paper towel just in case I need to wipe something off, and my meat thermometer to test the temperature. So it says you will need at least 3 people for this activity, 1 person to time, 1 person to read the temperature, 1 person to record the information. Okay, I would suggest not doing this by yourself and do it with someone else. I'm going to try to do it by myself. It's much easier to do it with people. That way, one person does one thing, that another person does another thing. That's why we typically do this in our expert groups. But you're at home, so use your family members to help you. Okay, then it says, look at the chart in the activity manual. Predict which pairs of substances will cause a chemical reaction. Record your predictions. So if you look at this chart in your activity manual, you'll see there's hydrogen peroxide and yeast. Do you think the temperature will rise, temperature will drop, or temperature will stay the same? Now, I actually think the hydrogen peroxide and yeast, the temperature will drop. So I'm going to mark just an X there. Water and salt. So I think the temperature will rise, temperature will drop, and the temperature will stay the same. I think it's going to stay the same. I'm going to put an X there. And vinegar and baking soda. Will the temperature rise, drop, or stay the same? And I think it's going to rise. So I'm going to put an X there. All right. Now we can actually begin our experiment. So it says pour 30 milliliters of hydrogen peroxide into a cup. Now remember, 30 milliliters is 6 teaspoons. So you have to be very careful because these are chemical substances. You don't want to get them in your eye or on your hands and then touch your eye. So be very, very careful when measuring. I've got 1, 2, 3, 4, 5, and 6. So I have 6 teaspoons, teaspoons. And then it says, measure and record the starting temperature of the hydrogen peroxide. Keep the thermometer in the cup. So here's my meat thermometer, and I'm just going to stick it in the cup, and I'm going to measure the starting temperature. Now I'm just looking at my little screen on my meat thermometer, and it says the starting temperature is 70 degrees Fahrenheit. So I'm going to put that on the bottom chart where it says starting temperature for hydrogen peroxide, 70 degrees Fahrenheit. Now, I'm going to measure 5 milliliters of yeast. So I'm going to take my teaspoon again, take 1 teaspoon of yeast, okay. You're also going to make sure to stir it in. So I'm going to take the meat thermometer out just a little bit, stir it up, and then record. My stopwatch is going to start now, starting with 10 seconds. Okay, so I started a little bit late. It's already gone up to 71 degrees. Okay, now I'm at getting close to 20 seconds. I'm at 72 degrees. Waiting to go up to 30 seconds. 30 seconds, and I'm still at 72 degrees. I'm at 40 seconds, still at 72. 50 seconds, still at 72. Oh, 60 seconds, I'm at 73. 70 seconds, I'm at 73. 80 seconds, I'm at 73. 90 seconds, I'm at 73. 100 seconds, I'm at 74. 110, I'm at 74. 120, I'm at 74. Okay, I'm going to stop my timer. So, if you're doing this at home, you'll see kind of a funky reaction that happens with the hydrogen peroxide and yeast. And I'll show you what mine looks like. You see how it got a lot bigger? It kind of got foamy and thick, and it smells like, kind of like bread. Okay, so that's what that happened, and it got a lot thicker. So I'm going to set that off to the side. I'm going to clean off my meat thermometer. Okay, set that off to the side. Now, a reaction occurred. It's asking, did a reaction occur? Yes, a reaction occurred. Actually, it was opposite than what I personally thought. I thought the temperature would go down. The temperature actually went up. So, now we're going to move on to the next step, okay? We are going to look at the water. So I've already measured out 6 teaspoons in this larger measuring bowl. And so I'm just going to pour that into there. Okay. Set that off to the side. And I'm going to record the starting temperature. Now I've used water on the colder side when I poured that in. It doesn't matter what temperature the water is, because if a reaction occurs, it's either going to go up or down. I'm going to put this off to the side and my yeast off to the side. Okay, it's settled at 68 degrees Fahrenheit. Now I'm going to take my salt and I'm going to add 1 teaspoon or 5 milliliters of salt to my water. Okay, I'm going to stir it up with my plastic knife and then record the temperature. And start my timer, 10 seconds. Seconds, still at 68. $20 seconds, still at 68. $30 seconds, still at 68. And I'm writing this as it goes, by the way. 40 seconds, I'm at 68. $50 seconds, I'm at 68. And I'm reading it from my meat thermometer right here. 60 seconds, I'm at 68. $70 seconds, still at 68. $80 seconds, shocker, still at 68. $90 seconds, 68. 100 seconds, 68. 110, 68. And 120 seconds is still 68. Okay, I'm gonna stop my timer and reset it. So, did a reaction occur? No, the temperature did not change. It didn't go up or down. It just stayed exactly the same the whole time. I'm going to take my meat thermometer out and just rinse that off a little bit. Okay, so no reaction with the water and salt. It really just, most of the salt kind of, some of it mixed in, most of it settled at the bottom. Okay, now our last reaction is vinegar and baking soda. So I'm going to take my teaspoon, remember 6 teaspoons of baking soda, or of vinegar is 30 milliliters. So I've got a big container. Got 1, 2, 3, 4, 5, 6. Okay. Now I'm going to warn you, there is a bit of a reaction with this one, I believe. I'm trying to remember. Okay. then I record the starting temperature. So the starting temperature of this vinegar, it's going down. I guess it's colder. Especially make sure you kind of wait a little bit when you're recording the temperatures, because you can think that it's at one temperature, but then it might go down. So like it was at 66 for a while, and then it just went down to 65. Okay, I'm going to say the starting temperature is 65 degrees Fahrenheit. So now I'm going to add my teaspoon of baking soda to my vinegar. Don't get freaked out with the reaction, okay? No need to really mix it up. But now I'm going to start my timer, okay? Oh wow, it went down to 60. Woo. And that wasn't even 10 seconds. Okay, at 10 seconds it was 56. Wow. "20 seconds, 56. Let's see. 30 seconds, 56. 40 seconds is 56 degrees. 50 seconds is 56 degrees. 60 seconds is 56 degrees. 70 seconds is 56 degrees. 80 seconds is still 56. 90 is 56. 100 is 56. 110 is 56. And 120 is 56. Okay, so what I noticed is that the temperature dropped really quickly, like less than 10 seconds, but it stayed there for a while. So did a chemical reaction occur? Yes, it still did, even though it dropped real quick and then it stayed the same. Because it dropped at all, that means that there was a chemical reaction. So I'm going to take my thermometer out. Ooh, it's cold. Okay, I'm going to wipe that off. And what you're left with is kind of a little bubbly solution that almost looks like soda. Okay? So, on the back, on page 112 of your activity manual, you can go ahead and graph the time in seconds with the different colored pencils. And then answer the questions at the bottom with the conclusion. It says, which baking soda produced a chemical reaction? Okay, so there's actually two, right? There was hydrogen peroxide and yeast, and vinegar and baking soda. And then how do you know whether a chemical reaction occurred? So with the hydrogen peroxide and yeast, we know that the chemical reaction occurred because the temperature went up. And actually it slowly went up the whole time. I wonder if we kept it in longer, how hot it would have gotten. And then also the temperature of vinegar and baking soda dropped drastically as soon as I poured it in. It says, were the reactions you observed exothermic or endothermic? Now, this is actually both. So for the hydrogen peroxide and yeast, that was exothermic because it produced heat. The one with the vinegar and the baking soda was endothermic because it decreased in heat. Okay, now this lab is completely optional and it's It's up to you. It's actually extra credit if you want to, but honestly, I think it's a really fun lab to do with all household items that most of you probably had. Now, I do not want you to go out and get any if you do not have it, okay? It's just fun for you to do, and I hope you enjoy watching the lab from my home. Bye.